Hello control friends, welcome again to another post on the page Control Automático Educación. My name is Sergio Castaño and today we are going to start a new course here on the page, which is the MATLAB course. We are going to learn how to use this important engineering tool from scratch. For those who know nothing about MATLAB, this course is ideal for you. Remember that everything we will cover in this course can be found in the description of this video, where you can go directly to the Control Automático Educación page and see all the content of each video. If you want to follow this course and learn more, you can watch the playlist right here. So let's start with our Well friends, since this is the first video, we are going to see an introduction to MATLAB. We'll understand why it's worth learning this software and its importance in different branches of engineering. MATLAB is a sophisticated engineering tool available to solve mathematical problems in a very simple way. The word MATLAB is just a simplification of its full name, Matrix Laboratory, which means a matrix lab. MATLAB, as its name suggests, is a matrix laboratory, meaning that its specialty is solving vector and matrix problems. But we can also use it for numerical calculations with scalars, symbolic integrals, and we can do a wide range of things: simulate processes, create programs to install on computers, build graphical interfaces to present specific engineering programs to users, and much more, all of which we'll cover gradually in this course from Control Automático Educación. Just like MATLAB, there are other similar software tools used in all fields of engineering. Tools like Maple, Wolfram, Mathematica, and MathCAD. These four are just examples. They are very similar programs used for numerical computing and solving engineering problems, allowing students or researchers to clearly demonstrate the concepts they've studied or investigated. Which one is better? That depends. MATLAB is great for working with matrices and vectors, but for example, MathCAD is better at solving math problems more intuitively. Each one solves specific problems better, but in general, they're all quite similar. I have friends and colleagues who use Wolfram Mathematica and are excellent with it. Let me know in the comments which one you prefer and why you think it's better than the others. But, well, since in this course we'll focus on MATLAB, let's continue exploring our software. In terms of programming, let's see where MATLAB fits. Imagine a pyramid. At the bottom, we have the most basic programming languages, low-level languages. The most well-known of these is assembly. Assembly is a very basic programming language that uses instructions to tell the machine what to do to solve an algorithm. Using assembly is extremely difficult because you must fully understand how the machine works, memory banks, and processing. Programs written in assembly often only run on the machines they were written for, and migrating them to other processors can cause compatibility issues. Next, we have mid-level languages like C, C++, or Fortran. These are more specialized, very powerful, and sit one level above assembly. With these languages, we can build much more useful and practical applications for engineering or academic life. Many important tools and software have been written in mid-level languages. MATLAB itself was initially written in Fortran. These languages allow for easier development since they bridge the gap between humans and processors. Above that, we have high-level languages like Python and Java. As we go up this pyramid, it becomes easier to write programs. Solving a problem in assembly is very hard, but solving it in Python or Java is much easier because these languages already have tons of built-in functions that save us time, like matrix multiplication, for example. Then we have MATLAB. MATLAB is an interpreted language, a very high-level language, which makes it extremely easy to use. That's why it's widely used in research centers and universities. With MATLAB, we can easily explore and test concepts from our engineering studies. Generally, MATLAB is used for designing and prototyping projects. But when it's time to implement a solution in real-world industrial settings, MATLAB might not be the best choice due to its slower execution. Being high level means the code takes longer to process. So, this is the trade-off between high and low level languages. A program written in assembly takes a long time to develop, but it runs very fast. On the other hand, a program written in MATLAB is easier to build but slower to execute because the processor needs to interpret many layers to reach the machine code. That's why in engineering projects we often design and validate everything in MATLAB first. Once it works, we migrate the logic to C, Python, Java, or Fortran, languages that are faster and more efficient for implementation. What kinds of applications are interesting to study with MATLAB? Well, MATLAB has tools for many engineering fields. For example, in automatic control, like in Control Automatico Education, we can model control loops, implement classical and advanced controllers, and solve algorithms to control real processes. MATLAB can also be used for modeling physical and chemical processes, such as distillation columns, reactors, or mechanical systems like CNC motors, and electrical systems like coils or capacitors. All of these can be modeled in MATLAB. We can also use MATLAB for image processing, detecting faces, objects, or defects. There are toolboxes for image capture and analysis. It's also widely used in process optimization, helping us find maximums, minimums, global optima, or best operating points in systems including financial ones. MATLAB is great for creating 2D and 3D plots for detailed engineering analysis. Signal processing is another area, applying Fourier transforms, analyzing filters, and so on. And one of the most popular topics today is neural networks. MATLAB allows us to design and implement neural networks and artificial intelligence models that can be applied to many areas in engineering. This course is based on MATLAB 2017, but if you have an older or newer version, don't worry, you can follow along just fine. The main differences between versions are usually a few added or removed functions and some graphical interface improvements. The core content and structure stay the same, so regardless of your MATLAB version, you can follow this course. This was just a quick overview of what we can do with MATLAB. That's why it's important to follow this course. We'll go from the basics to more advanced topics so you can apply everything in your specific engineering field. Leave a comment telling me how you'd use MATLAB, what your engineering area is, and what you'd like to learn. See you in the next video. You can follow me on social media, subscribe to my channel by clicking on my photo, and activate the notification bell. And don't forget to watch the next video.